So next renewable energy source is wind energy. So what is the wind? What is the cause of flowing of wind? So due to uneven heating of earth surface by the sun. So because of uneven heating at one surface and other surface in the earth will cause the flow of wind. So the main source for flow of wind is sun. Due to uneven heating of earth surface by the sun, it may cause flow of wind from one direction to the other direction. So what is the origin of wind? So wind is caused by differences in the atmospheric pressures developed due to uneven or differential heating of the earth. So due to uneven heating of earth surface due to the sun, it causes flow of wind. When a difference in atmospheric pressure exists, air moves from the higher to the lower pressure area, resulting in winds of various speeds. So, globally, the two major driving factors of large scale wind patterns are the differential heating between the equator and the poles and the rotation of the planet. So, this is the main two major factors driving the wind. On a rotating planet, air will also be deflected by the except exactly on the equator. So, coming to the local winds. So, wind is caused due to differential heating of land surface and water bodies due to solar radiations. Differential heating of slopes on the hillsides and that of lowlands. So, these are the wind distribution across various areas like hill areas, buildings or cities, major cities, mountains, and this is at the time of clouds. So generally, wind classification that is based on the wind speed and how the typical cyclone classifications at average of 10 minutes average. So this diagram shows the general wind classification for average of 10 minutes. Now, how it will affect the wind speed with respect to the potential damage. When the wind speed is around 65 to 85 miles per hour, so it may not cause any damage or it may be very minor damage, like surface of some roofs or some damage to the gutters or sidings. So that is effect of 0. Effect 1. When the wind speed is above 85 kilometers and below 110 miles per hour, it may cause moderate damage, roofs severely stripped, mobile homes overturned or badly damaged, loss of exterior doors, windows, and other glass broken. So the diagram shows the wind speed when it is above 85 miles per hour and below 110 miles per hour. When the wind speed is above 111 miles per hour and less than 135 miles per hour, there may be considerable damage. Roofs turn off well constructed houses, mobile homes completely destroyed, large trees snapped or unprotected, so light object missiles generated, cars lifted off ground. So when the wind speed is above 136 miles per hour and below 165 miles per hour, so severe damage will cause. So severe damage to large buildings such as shopping malls, trains, trees, etc. When it is extremely damaged, that is when the wind speed is above 166 and below 200, it may cause extremely damage. When it is greater than 200 miles per hour, total destruction takes place. That is the wind speed based on the potential damage. When you have the less wind speed, we may have minor or less damage. When the wind speed is above 200 miles per hour, that it may cause total damage, that is based on the wind speed. So the occurrence of total destruction is very very less, that is only 0.1%. So this is a wind speed variation with respect to the height above the surface. So the graph shows on x-axis wind speed and y-axis height above the surface. In general, the wind speed increases with height from the surface to the upper troposphere. The pressure gradient increases with height. The wind speed increasing with height due to less friction. Near the ground, wind speed becomes zero due to surface friction. The density of the air is highest at the surface and decreases with the height. So wind power applications. Generally, the wind powers are used for wind pump, that is water transport in remote areas. So off-grid electric power source, household applications, and grid-connected electric power source, that is in wind farms. So types of wind turbines based on the direction to the ground axis with respect to the ground. We have the horizontal axis wind turbine and vertical axis wind turbine. Horizontal means it is in parallel with the earth surface. Vertical means it is perpendicular to the earth surface. So based on the axis with respect to the earth surface, the wind turbines are classified into two types, that is horizontal axis wind turbines and vertical axis wind turbines. So this is a diagram for horizontal axis wind turbine and vertical axis wind turbine. So coming to the horizontal axis wind turbine, it contains a rotor, gearbox to increase or decrease the speed. Means to vary the speed, we are using the gearbox, and we have the generator, which converts the mechanical energy into electrical energy. So we are using a stand or tower where we are constructing the gearbox and generator on the tower of the earth surface. So when the wind hits the blades of the rotor starts rotating so that mechanical power is given to the gearbox so that it may vary the speed, that is giving electric mechanical power to the generator so that the generator converts the mechanical power into electric. Coming to the vertical axis, so in vertical axis, the generator and gearbox are placed on the earth surface, whereas in horizontal axis, it is placed on parallel to the earth surface. That is the basic difference between horizontal axis and vertical axis wind turbine. So in horizontal axis, the gearbox and generators are placed parallel to the earth surface, whereas in vertical axis, the gearbox and generators both are placed on the earth surface. So it again contains the rotor, gearbox, generator, and we have the turbines. So horizontal axis wind turbine. It is similar design to a windmill. It has blades that look like a propeller that spin on the horizontal axis. So the horizontal axis wind turbines have contains the rotors and electric generator at the top of the turbine, and they must be pointed into the wind. Small turbines are pointed by the simple wind placed square with the rotor blades. While large turbines generally use a wind sensor coupled with a servo motor to turn the turbine into the wind. So most large wind turbines have gearbox, which turns the slow rotation of the rotor into a faster rotation that is more suitable to drive the electric generator. So we have the gearbox so that we have to rotate the generator. So we know that if the generator runs at a minimum speed, Whenever we have less mechanical power, so we can't rotate the electric input, so that generator, so that it won't convert into electric power. The main advantage of horizontal axis wind turbine. So the wind speed can increases by 20% and the power output by 34%. When the speed increases by 20%, the power is almost increased by 34%. It is having the high efficiency since the blades always move perpendicular to the wind. Why? Because in vertical axis, the blades, so the gearbox and generators are placed on that surface. So in horizontal axis, the wind blades are perpendicular to the wind so that it receives power through the whole rotation. So types of horizontal axis wind turbines. We have the single bladed horizontal axis wind turbine, double bladed horizontal axis wind turbine, three bladed, multi bladed, and we have the upwind and downwind. So mostly the horizontal axis wind turbines are classified based on the number of blades. Whenever we have the single blade, it is termed as single bladed horizontal axis wind turbine. Whenever we have the two blades, it is termed as double bladed wind turbine. Whenever we have the three blades, it is termed as three bladed wind turbine. Whenever we have the n number of or multi number of blades, it is termed as multi bladed wind turbines. Based on the wind direction, it may be upwind or downwind. Based on that, again, they are classified as upwind horizontal axis wind turbine and downwind horizontal axis wind turbine. Next, coming to the vertical axis wind turbine. So, vertical axis wind turbines are the main rotor shaft arranged vertically. So the wind turbine does not need of pointed into the wind. Why? Because it is parallel to the earth surface. So there is no need of making perpendicular to the rotor blades to the wind. That is occurs in only horizontal axis wind turbine. So in types of vertical axis wind turbine, mainly we are using Darius and Serodius type wind turbines. So we have the Darius rotor and Sevonius rotor type vertical axis wind turbine. So they have good efficiency but produce large torque, ripple, and cyclic stress on the tower. So that is a 7 year type wind turbine. So the advantages are, so there is no need of yaw mechanism is needed. It can be located near the ground, making it easier to maintain the moving parts. So generally, vertical axis wind turbines have lower wind startup speeds than the typical horizontal axis wind turbines. They can build at locations where taller structures are prohibited. So it is situated very close to the ground, can make advantage of locations where rooftops, hilltops, and passes funnel the wind and increase the wind speed. So coming to the disadvantages, so they have reduced drag, produce more energy, especially those funnel wind into the collector area. Having rotors located close to the ground where wind speeds are lower and do not take advantage of higher wind speeds above. This is a disadvantage of vertical axis wind turbines. So wind energy conversion system. So in wind energy conversion system, so this conversion takes place in two steps. So first we have to convert the wind energy into kinetic energy and that kinetic energy again converting into electrical energy. So the energy conversion chain is organized into four subsystems. Aerodynamic subsystem consisting of mainly turbine rotor, drivetrain generally composed of low speed shaft coupled with turbine drive hub, electromagnetic subsystem and finally electric subsystem. These are the main four subsystems that we are using for wind energy conversion systems. So this is a wind energy conversion system where it contains the wind turbine blade, and we have the control board and communication where we have to use the rectifier which converts the AC to DC, and that DC is giving to the DC link, and then again giving to the inverter which again converts DC to AC, that we are giving to the grid. So it contains the rotor, and it contains the gearbox, and then it contains the electric generator. When the rotor hits the blades of the rotor starts rotating so that it supplies the mechanical energy to the gearbox through shaft. That mechanical energy is coupling to the generator so that it converts the mechanical energy into electrical energy. So types of generators that generally used for wind turbines. We have the induction generator. Typically, we are used for electric generator, and we have the permanent magnet alternators. So fixed speed wind energy conversion system. So fixed speed means it has to operate at constant speed. Why? Because we know that wind speed is not constant. So when the wind speed is not constant, by default the rotor speed is also not constant. So that's why we have to connect the wind energy conversion system with induction generator and capacitor bank so that we have to rotate at constant speed. When that constant mechanical speed is giving to the generator so that it converts into electrical energy. So these are the fixed speed energy conversion system. So next one is variable speed wind energy conversion system. So variable speed wind turbines are currently most used wind energy conversion system. So it is possible due to polytronic converters like double fed induction motor based wind energy conversion system. So in fixed speed we are using the induction generator, whereas in variable speed we are using the double fed induction generator. So this is a diagram of variable speed energy conversion system. So next last one is about the characteristics of power versus wind speed characteristics. So the diagram shows on x-axis we have the wind speed, on y-axis we have the power. So we know that we have the wind energy conversion system. So according to Beck's law, the maximum conversion efficiency of the wind energy is only 27%. The maximum possible wind energy conversion efficiency of the wind is only 27%. So that the remaining 73% is wastage from conversion of wind energy to electrical energy. Only 27% of wind energy that we are utilizing for conversion into electrical energy. So that's why the wind plant has very less efficiency as compared to the remaining renewable energy sources. So the main relation between the wind speed and power. So power is proportional to the cube of the wind speed. Means when the wind speed is increases, the power is almost three times increased by three times. That is the relation between power versus wind speed. So here at 5 meters, that is a cut-in voltage of the wind speed. At generally 5 meters per second wind speed, there is no production of output power. When the power increases and when it reaches the maximum well, that is at 12 meters per second, the wind speed, the power is almost reaching the constant, that is rated power, that we reaches the rated speed, rated power. So at rated wind speed the rated power achieves. So the relation between power and voltage and wind speed is given by power is proportional to the cube of the voltage. According to Bett's limit, the maximum conversion of wind energy to electrical energy is only 27%. That is the ratio of energy efficiency of the wind that generating to the electrical energy.